So far, we've studied about atoms and molecules, and we've learned that we can bring atoms together with bonds, either covalent or ionic, to form molecules. So what I'm doing right here is I'm using a covalent bond to bond hydrogen and oxygen. And if I do this twice, take two hydrogens and bond them to oxygen, I get a molecule of water. So I used three different atoms with a couple of covalent bonds to form a molecule of water. Now, this is just one molecule of water. Let's say I have a whole sample of water. So this is liquid. You can tell that there's quite a bit of water in here. It's quite unlikely that this water is formed by just one molecule. There must be millions of molecules in there. Also notice how those millions of molecules seem to be sticking together, because my sample of water isn't suddenly leaping out of the bowl or evaporating very quickly in any manner. So all of these molecules of water that are in my bowl must be connected together somehow. So we've established that any sample of water, as long as it's even more than a drop, is going to have multiple molecules. So there must be something that connects all these water molecules together in order to form liquid water. That's going to be the focus of this lesson. We're going to be looking at something called intermolecular forces. Intermolecular forces are also abbreviated as IMFs for intermolecular force. So let's look at what an intermolecular force is. What you've learned so far is that molecules are held together by covalent bonds, such as these, but it is possible to have multiple molecules be held together by something else that binds them, and the something else that binds them, we call those intermolecular forces. So IMFs bring molecules together while the individual covalent bonds keep the molecule together. So what makes this H2O are the covalent bonds, but what allows H2O molecules to combine together to form liquids are intermolecular forces. So intermolecular forces are responsible for states of matter. And you know that there are four states of matter: solid, liquid, gas, and plasma, but we're only going to worry about solids, liquids, and gases. How many IMFs are present in any particular sample determine whether something becomes a solid, liquid, or a gas. So let's take a look at a few examples, starting with gases. I'm going to use water molecules again. When water is a gas, we either call it steam or water vapor. So whether it's steam or water vapor, you still have H2O, two hydrogens and an oxygen. It's just that these H2O molecules don't have anything connecting them, which allows them to move around wherever they want. So this movement of H2O molecules causes it to be a gas, and that movement is only possible because there's nothing holding these molecules together, which means they can just go past each other without interacting. Okay, so when H2O is a gas, we call it steam or water vapor, and we know that these molecules can move wherever they want. But what about if we're looking at a liquid? If we're looking at a liquid, such as what we saw at the beginning, this example right here, you can tell the molecules have some degree of freedom. That's why this water can flow from one place to another. But you know that this water, the molecules in this water, has less freedom than steam or water vapor because they're not able to move wherever they want. They're still being held by the container that I'm holding. So with liquids, you still do have IMFs. They are weaker. So for example, if I have these two water molecules, they still have intermolecular forces between them, which I'll show with these dotted lines here. So they still have these intermolecular forces between them. But the thing about liquids is these intermolecular forces can form and then break and then form again with something else. So these molecules can basically switch around, and that's what allows for a liquid to flow. But the fact that these exist tells me that they are somehow bound together, and that's why the liquid stays in the container. So liquids have IMFs, but they're weaker and they're more flexible and they can move around a lot more. As opposed to solids, where your IMFs are rigid. Rigid means they cannot move a lot, which means if you look at ice now, ice is basically solidified water. These molecules cannot move apart from each other. So I could put another molecule of water here. I could put another molecule of water here. And these molecules would stay together. These IMFs would not move, they would not change, and these cannot move around because they're in a solid. So intermolecular forces determine whether this same molecule of water can be a gas, liquid, or solid. When it's a gas, it can move around and it has no intermolecular forces. When it's a liquid, the intermolecular forces are more flexible, and when it's a solid, the intermolecular forces are rigid. So we know that intermolecular forces cause different states of matter. What else can intermolecular forces cause? So we've only looked at water as an example, but it's important for you to know that different substances have different strengths of IMFs. And looking at intermolecular forces can help us determine what the viscosity of certain substances are and their boiling point. So stronger IMFs mean that substances will have stronger viscosity. So what exactly is viscosity? Let's take a look at an example for two different liquids that have two different viscosities. So we're going to take a look at water. In order to take a look at water's viscosity, let's use a spoon and see how easy it is to make water flow. So you can see that this water flows relatively easily. Let's take another substance. I'm going to use honey and see how honey flows. So let me take a small amount of honey. Notice how the honey doesn't move very easily. It takes forever for it to go down this spoon. See how slowly it moves? So that's because the molecules that form honey, the sugar molecules, have much stronger IMFs, and so that holds the honey together and doesn't allow it to move very freely, as opposed to water over here, which has weaker IMFs and can allow its molecules to move around more freely. So the strength of IMFs depends on what molecules you are looking at. So for example, honey has stronger IMFs than water. And since honey has stronger IMFs than water, it has a higher viscosity, which means it's more resistant to flow. It also has a higher melting point and boiling point, which means if I took a pan of water and a pan of honey and tried to heat them up till they boiled away, water would boil first because it has weaker IMFs than honey. Or if I tried to melt ice versus sugar, which is basically solid honey, ice would melt first instead of sugar because sugar has stronger IMFs.